Okay, let's look at a mole-mole problem. But rather than just a mole-mole problem, let's look at something that we're a little more familiar with. Let's look at a recipe. Alright, so let's consider baking some cookies. So my cookie recipe requires 3 cups of flour, an egg, 1 cup of milk, 1 package of chocolate chip cookies, 2 cups of sugar, half a cup of butter, and it's going to make 15 cookies. So we're all pretty comfortable with the idea that if I wanted to make 30 cookies, I would need 6 cups of flour, or I would need 2 eggs, 2 cups of milk, 2 packages of chocolate chips, 4 cups of sugar, and then a whole cup of butter. Alright, we're used to cooking and we're used to thinking like that. Manipulating a chemical formula or a chemical equation is no different. Alright, it's just the numbers aren't necessarily so clean, and it's not substances that we're always necessarily familiar with. Alright, but what if we treat manipulating this recipe as a chemical equation with some mathematical equalities? What if we say 3 cups of flour, alright, in terms of this recipe is equal to 15 cookies? Alright, this makes the assumption that every other ingredient is available in the required amount. I could also say that 1 egg is equal to half a cup of butter. And I'm also able to say that 2 cups of sugar are equal to 3 cups of flour. Okay, so this is, again, assuming that I make the 15 cookies and I have everything else that I need. Alright, so let's ask this question. How much sugar is required or is needed to fully consume or to completely react with, right, whichever term, both of those terms are going to come up in your future, completely react with 8 cups of flour. Alright, so 3 doesn't go into 8 evenly, so we would need to do a little bit of mathematical manipulation here. So why don't I write this out as an expression? 8 cups of flour times 2 cups of sugar divided by 3 cups of flour. So we've already said that 2 cups of sugar is equal to 3 cups of flour. So what happens to my units there? Okay, so 8 times 2 divided by 3 gives me 5.33. So cups of flour, alright, eliminate one another, and this leaves me with cups of sugar as my unit. Well, what if I were to treat a chemical equation like this? How about rather than thinking about a chemical equation any differently, what if we want to know, let's say, a quantity of product based on a certain amount of reactant that was used? So why don't we say how many moles of ammonia? Okay, ammonia is a nice simple molecule. All right, are produced or are formed when 4.8 moles of hydrogen completely react with sufficient nitrogen. Okay, we'll give it an equation here. Alright, I wouldn't expect anybody to be able to predict the equation at this point. Okay, the Haber process is a very common chemical process, one in the equation you'll be quite familiar with. Okay, but don't worry about that, I will give you the equation. So I'm going to say 4.8 moles of hydrogen times 2 moles of ammonia, alright, divided by 3 moles of hydrogen. So notice where I'm getting the 2 and the 3 from. Those are the coefficients in the balanced chemical equation. Okay. Right, this is going to yield 3.2 moles of ammonia produced.